So section 10.5 is going to talk about polynomial and rational inequalities. I'm going to take an approach that's a little bit closer to the way you're going to see things in your WebAssign homework, at least in the beginning sense of things. And that is, they start out by looking at what are called the critical numbers. Now we're no longer trying to solve a polynomial equation or quadratic equation. This is an inequality. So emphasis on the inequality part of this right there, because you've got a greater than or equal to, or a greater than sign, less than or equal to, less than sign as part of your problem. It's going to start out by asking you to find the critical numbers. The critical numbers in this one are where this actually equals 0. So where does x squared minus 2x minus 15 actually equal 0? Well, we can solve that. Do we need to bust out the quadratic formula to solve that? No. What's your method of choice for this one? Factor. Good. So how does this one factor? -5 and +3, which gives you two solutions, right? Those two solutions are 5 and -3. Thank you so much. So your critical numbers here are 5 and -3. Great. How about the one below that? Well, the one below this is an example of a rational expression. So it's the ratio of two expressions. And you're really going to have to try and find the critical numbers in two parts. You're going to set the numerator equal to 0. So that's going to be x minus 4 equals 0, or x equals 4. And we're going to set the denominator equal to 0. And I'm curious to see what you're going to get here. How are you going to solve this one? Kiana?
For the first one, we don't have to get that x equal to 0.
Where? Up here?
Yeah, when we, so you know how we normally just change the sign? We don't need to change the sign.
Well, that's kind of effectively what you've got here. You did effectively change the sign. In this case, in my mind, I move the 4 to the other side, and when it changes sides, it changes signs.
I was talking about A.
Oh, the first one?
Yeah.
Well, again, you're just changing the sign to go from the binomial to this, or from here to here. You're just changing the sign on those numbers.
Okay.
All right? So how about this, though? How are we going to solve this, or what are the solutions? Can you maybe read them off? Let's start with this one. You got something times something equals 0. What makes this equal to 0 right here? -3. How about this? Where does that equal 0? Just 0. And those are your critical numbers here. So you're going to start by finding those critical numbers and decide, well, the critical numbers are, in this case, -3, 0, and 4. Now, what role do those play in solving these types of inequalities? Well, I'm glad you asked. We're actually going to look at a graph of the equation for this first one, y equals x squared minus 2x minus 15, and see what we see. So let me cut over to decimals here real quick. There's our graph. And let's see, might help if I typed in the right equation. Actually, let's just do this. Let me type in y equals x squared minus 2x minus 15. There we go. That looks like a little bit more like what I was expecting. You can see where this graph crosses the x-axis. There's your x-intercepts right there. Those are our critical numbers. But in a lot of problems like this, it's going to ask us for, well, where is this graph bigger than 0? And there's really two places. To the right of 5, so anywhere from here on up, the graph is bigger than 0. So to the right of 5. Or to the left of -3, this graph is bigger than 0. It's above the x-axis. So both of those sets of points are going to solve your inequality. Now, sometimes your inequalities will say less than 0. So if that was the case in a problem like this, you'd want this middle interval, because that's where the graph is below the x-axis. So there's a nice visual part to this. I don't emphasize that part too much because we're going to take an approach of testing points that's going to work for us in more difficult problems. Let's move down to example B here and actually do one of these problems all the way through. So we've got x squared minus 4x minus 5 is greater than 0. Keep in mind that's not a greater than or equal to, it's greater than 0. So example B, x squared minus 4x minus 5 is greater than 0. Here's what I'm going to suggest. Let's first of all find our critical points. Those are going to be where x squared minus 4x minus 5 actually does equal 0. So where's that going to happen? Yep, let's factor it. Good. Carl, any idea how this would factor?
Minus 5, positive 1.
Nice. Minus 5 and positive 1. Pfeiffer, what's our two solutions here? X equal 5, x equal negative 1. You know what? I'm going to just draw the graph here. We can take a look at it real quickly on Desmos. I do think I have that one up here. That's this one. And you can see exactly what we expected. The graph's going to cross its x-axis at negative 1 and 5. But let me draw that here for us so we can kind of mark it up a little bit and look at this graph a little bit more. What we want is we want to know where this graph is greater than 0. So something like this, here and here. Those are our points at negative 1 and 5. Well, the answer to this inequality, where it's actually greater than 0, is anything to the right of 5 or to the left of negative 1. Now, how would I write that in terms of an interval notation? Well, let's work with this interval first. Remember, interval notation is always your left-hand endpoint and then your right-hand endpoint. What's at the far left end of this interval? Negative infinity to negative 1. Ah, well done. Parentheses. I didn't even get to get the question out. You've got the answer for me. We're not going to include the negative 1 because this is greater than 0, not greater than or equal to 0. Union, keep going. 5 to infinity. And again, parentheses on that one. Great. Antonio.
If it's greater than, wouldn't that make it go this way? Or because
We're just looking for where this graph is above the x-axis. That's where it's greater than. It's the y-coordinate is greater than 0.
Okay.
So that's what we're looking at.
I understand.
Yeah. Now, let's do this a more mechanical way. Now, I know that you can kind of see this, and a lot of times you can expect a plus, minus, plus pattern, and that's great. But when we start working with our rational inequalities down here, the graphs get a little bit more tricky. And so we're going to take an approach that's going to work for all these things. And I want you to take out your graphing calculators on this one. We're going to redo this problem kind of more mechanically. So I'm just going to draw a number line again. I'm not going to worry about the graph. I'm going to put my points on the number line. This number line gives us certain intervals. What are those intervals? Well, those intervals are going to be negative infinity to negative 1, negative 1 to 5, and 5 to infinity. What we're going to do is test points in this expression and see where they're positive and see where they're negative. And then we'll just choose the positive intervals. So what are some test points in each of these intervals? Well, something to the left of negative 1. So maybe negative 2. Something in here, Maybe a 0? What about something in here? 6? Sure. You could do 6 or 6 million. It doesn't really matter. Now let me show you something about your graphing calculators that's really cool. They can help out immensely with these types of problems. There's a little setting that I want to adjust for you first, and that is this. You're going to hit the second key and then the window key. Now I'm assuming that you've got a TI graphing calculator. Once you've got to that menu, then come down and make sure that independent is set to ask and dependent is set to auto. So scroll down. If those are different, then just hit enter, or cursor over and hit enter again. But that's all that matters. This table start and delta table don't matter. These two are what I want here. Leave these settings here for the rest of your natural life, okay? And you'll be good. Now, let's put in our equation into the equation editor. Hit the y equals key. Let's type in our equation, which is x squared minus 4x minus 5. And that x key is right next to the alpha key. It says xt, theta, and n. If you want to know what the rest of those things do, take my trig class. All right, so does everyone got that equation in their equation editor? Now here's the cool thing. Once we've got that in here, we can get our calculator to evaluate this expression at any point we want. So hit the second key, then the table key, and that should take you to something like this. Now I've got some values in here, so I'm just going to hit this delete key and get rid of them. All I want to do is I want to look at the values that I cared about, the ones that you chose. So let's see, -2, 0, and 6. All right. Now we could have done one of these in our head, right? You could plug in x equals 0 here and get 0 minus 5 is minus 5. But you know what? We've already got the equation in, so we'll do all these up here. The information that we need is not that I got a -5 or a +7. It's that I got a positive and then a negative, then a positive. So it's pretty quick like that. It's just positive, negative, positive. And since my equation is asking me where does x squared minus 4x minus 5, where's that greater than 0? Do I want the positive intervals or do I want the negative interval? The positive one. So this and this are my answers. So I get the same thing as before. I get negative infinity to -1 union 5 to infinity. Now in a problem like this, it might feel like extra work to do it this way. But I assure you that when it comes to the rational polynomials, the work gets a little bit more challenging, and you're going to want to do it on the graphing calculator. It's a much more efficient way to do it. Okay, so we got the same answer twice. This one down here, and this one here. You can do it either way, but I would recommend that you do it by testing points. All right, comments on example B here. We'll do a few more, actually a bunch more. Let's do another kind of warm-up problem with a polynomial before we start working with our rational polynomials. So this would be example C. Our polynomial this time is x squared minus x is greater than or equal to 20. Well, there's one thing we got to take care of initially. What about the 20? Well done. Nice. Well done. We want to get that 20 to the other side, because that 20 on the other side leaves a 0 on the right-hand side. So I've got x squared minus x minus 20 is greater than or equal to 0. Let's find our critical points. So our critical points, well, let's see. That's going to be where x squared minus x minus 20 equals 0. George, can you maybe help me out here a little bit? How's that going to factor? That's a minus, so one of these has to be a minus, one of them has to be a plus. Two numbers that multiply to negative 20 and add to positive, or excuse me, add to negative 1. What would that be? 4 and 5.
It's all here. I just want to know if I should fill something out. Do I have to fill anything here?
You're all set. I took care of it.
Okay.
Thanks.
Thank you.
Okay, so minus 5 plus 4. What are our two solutions then? 5 and negative 4. Let's put those on the number line. In fact, we can do it up here if you'd like. Doesn't matter. Nah, I think I'll just draw another one down here so I can mark it up a little bit more. So here's our number line. Negative 4 and 5. Let's think about the intervals that this creates. Charlie, help me out. What are the intervals that I get here? What's the negative infinity? Negative 4. Now because this is a greater than or equal to, I'm actually going to put a bracket here because I can include the negative 4 this time. It's greater than or equal to that one. Cool? How about the middle one? Negative 4 to 5. Again, I'm going to use brackets. And just as kind of a reminder or a heads up, infinity and negative infinity always get a parenthesis. If you put a bracket, I'm not going to mark you wrong, but you might get a frowny face, which is almost as bad. All right, LOL. Before we decide which one of these we want, we've got to change our expression in our calculator. The new expression that we want is this one right here. Where you get 0 on one side, that's where you want to test your points. So test points here. You don't have to have it factored, doesn't matter. So that means going back to your equation editor and changing your equation. This time I've got x squared minus x minus 20. So just hit the y equals key, change out that equation. Bachra, I need some test points here to test. So what would be some good test points in each of these intervals?
Negative 3.
Negative 3 would actually be in this interval.
Oh, sorry. So negative 5.
Negative 5.
Negative 2.
Negative 2.
And 6.
Sure. Negative 5, negative 2, and 6. Great. Let's go up here. Let's go to our table. You hit the second key, then the table key. All your settings should still be good. Let's delete all these values real quickly here and start all over with negative 5, negative 2, and 6. Be careful when you're plugging in negative values like negative 5 and negative 2. Use this opposite key on the bottom of your calculator, not the subtraction key. The information I need off this is that it tests out positive, negative, positive. So, okay, let's put that in. That's going to be positive, negative, positive. Which interval or intervals are going to satisfy this inequality? Is it going to be the positive ones or the negative ones? Maybe the positive intervals. So your answers are already right here. So we want to just circle both of those. That and that are our answers. So overall, you're going to get negative infinity to negative 4. Negative 4 union 5 to infinity. I think on WebAssign you might have to put a comma. I don't know whether you're going to use the union there. Wow. There you go. There's your answer. Pebble? Madison?
I know I saw the union symbol on WebAssign.
Did you? Okay. I wasn't sure if they had it or not because I know sometimes they ask you to kind of list things there.
It's
So.
like the last section before the first test.
Okay. Let's move on down to example D. So we're going to kind of expand our work here a little bit. So example D. X squared minus 2x minus 3 over x minus 1 is less than 0. So there's a couple important changes that we're going to see on this one. But first things first, we got to find the critical numbers. So see if we can't do that. Now you might remember for the critical numbers, for a rational expression, we've got to find where the numerator equals 0 and where the denominator equals 0. So the numerator equals 0, that's going to be x squared minus 2x minus 3. The denominator equals 0, that's just going to be x minus 1. Well, that one we can do right away. This one needs to be factored. Iris, how's that one factor, please?
X minus 3x.
Awesome, thank you so much. And what's our solutions from there? Mackenzie, what do we get for our solutions? Perfect. X equal 3, x equal negative 1. Those are our critical numbers. Let's put those on the number line for ourselves. So let me crank out a number line here real quick. We'll put those on it. I don't try and space them evenly. The important thing though, and actually the requirement, is that you have them in the correct order. And the spacing doesn't matter so much, just as long as they're in the correct order, from left to right. So farthest to the left is going to be my negative 1, and then a 1, and then a 3. Now because this is a less than, not a less than or equal to, when I write up my intervals, I'm not going to include the endpoints. There's a little bit more to say about the endpoints, but we'll see that in example. One of our other examples, maybe example E or something else like that. But for now, it doesn't include the endpoints, so we're going to keep on going. Let's see. It's going to be negative infinity to negative 1, negative 1 to 1, 1 to 3, and 3 to infinity. I need some test points here. So what would be some good test points? Madison, you look like you're anxious to offer up some test points here. What will be some points in each of these intervals? Let me suggest a 0 here. Whenever it changes signs, 0 is a nice easy point to do. But what about the other ones?
Alright. I would do
-2.
-2.
Mm-hmm.
Now go 4.
Sure. Look, I mean, you can make these points as complicated as you want, but you're not going to get any bonus credit by putting, 4 million plus pi here. Just keep it easy on yourself, right? Do a 4. So we got to be a little bit careful about changing our expression. The expression that you're always going to be putting in your calculator is going to be this one here, where you've got 0 on one side and then one expression on the other side. So that's what you're going to put into your graphing calculator. Put into the graphing calculator. And that's going to take a little bit of care. I'll show you two different ways you can put that into your graphing calculator. So the first way is something that everybody can do. So if you got an older TI-83, then you can do it this way. And then for those of you who have an up-to-date calculator, I'll show you a different possibility. But if you're going to put it in kind of a nice tried and true way, you're going to need parentheses for the numerator. So x squared minus 2x minus 3. Then write parentheses. You need to close off the numerator. Divided by, and then parentheses around the whole denominator, x minus 1. Now that's going to work pretty nice. But for those of you with, an up-to-date calculator, your software is up to date, and you've got a TI-84 Plus or something like that, then there's another possibility that eliminates these parentheses. If you hit the alpha key, then the y equals key, that's going to give you the ability to do a straight up and down fraction. So just choose the number 1, type in a 1 or press enter. And now I can type this in without the parentheses like that because it knows what the numerator is and it knows what the denominator is. X squared minus 2x minus 3 divided by x minus 1. The only downside to this is that sometimes your output in our table is going to look a little funky. It's just going to give you fractions. But you should still be able to determine positive and negative regardless. So one way or another, you have to put that new equation into your calculator. Let's go to our table. Oops. Go to our table and delete those values here. Let's type in the ones that Madison suggested, -2, 0, 2, and 4. So you can see a little bit of the difference. That other expression, that second one that I typed in, gives me a fraction, whereas this gives me a decimal. But it's still telling me the same information either way. What information do I need to get from this table? Alex, what information am I looking for right here?
Just a positive.
Yeah, positive and negatives, right? So I want to know where it's positive, where it's negative. In this case, I think it was negative, positive, negative, positive. I think that was a pattern, right? Yep. So it was negative, positive, negative, positive. Thank you so much, sir. Which one of these intervals do I want? Do I want the negative intervals or the positive intervals? Which ones do I want? Uh-oh. You guys are disagreeing. I got a negative and I got a positive. Which one do I want? Somebody else cast a deciding vote. It's election season, so you can elect the right answer, right? Math by democracy. We'll vote on it. What do we got here? Do I want to know where this is positive? Is this going to be true when this is positive, or is this going to be true when it's negative?
When it's negative.
Negative, right? Because I want it to be less than 0. So my solution is going to be this interval and this interval. Those two intervals are going to be my solution. So overall, the answer is going to be negative infinity to negative 1, union 1 to 3. Comments or thoughts on example D? There's a good chance to get a little help. Let me play with example D just a little bit. So we'll do example D revisited. We're not going to do it all again, but I am going to make one important choice or change. And let's see what effect it makes. Example D revisited. So x squared minus 2x minus 3 over x minus 1. This time let's make it less than or equal to 0. And let's see what difference that makes. Well, for the most part, all of our work's going to remain the same. You're still going to have the same number line and critical points, so I'm not going to revisit all that. Let's put that there. In fact, I'm not even going to do any new test points. So I got negative 1, 1, and 3. But here's what's different. Now I got to consider the endpoints. So, can I use any of the endpoints? Oh, that's a good question. What would happen if I put in a negative 1 into this expression? Let's see here, because we've already got this plugged into our calculator. Let me clear out a little bit of this. And I'm just going to clear out these as well. I don't think I need these anymore. That's kind of muddling the issue. So if I put in a negative 1, I get 0. Is 0 less than or equal to 0?
Yeah.
Yeah, so I can use that endpoint. So the interval here is now going to become negative infinity to negative 1, bracket. And that same bracket is going to extend over here, negative 1. How about the point x equal 1? Plug that one into your calculator. Tell me what happens when you plug in a 1. Something going wrong? What'd you do wrong? Uh-oh, error. Did you make a mistake? Did I make a mistake?
No.
Why am I getting an error when I plug in a 1 here?
There's no graph on there.
Yeah, the graph doesn't exist there, that's right.
Makes it it doesn't solve it correctly, I would say.
What are you dividing by when you plug in a 1?
Zero.
You divide by 0. That's a mathematical no-no. You can't divide by 0. So we can't use 1. So does that mean it gets a bracket or parenthesis? If we can't use it. Parenthesis. So parenthesis around 1. How about can I use 3? Let's plug in a 3. Will 3 work? Yeah. 3 is okay because it makes the numerator 0. And 0 is less than or equal to 0. That's true. So these are my intervals this time. What you have to avoid is you can't let the denominator equal 0. It's still going to turn out to be, when you test your points, negative, positive, negative, positive. We still want the negative intervals. It's just that this time we're picking up a couple of the endpoints. But you can't include any endpoint which makes the denominator equal to 0. So the final answer here is negative infinity to negative 1, union 1 to 3, parentheses and brackets respectively. Whew. All right. Almost done. Almost done. I hope you're hanging in there. Let me just show you a little bit of work with example F. Usually I'm nicer than this on an exam, especially for a Math 1150 class. My Math 1540 class, and they're taking a test today, they'd probably appreciate the review that you're getting right now. They really would. So, example F. I'm going to change it up just a little bit. Let's do 1 over x is less than or equal to 2. So, the only change I made was that I made that a less than or equal to as opposed to just a less than. We got to whip this one into shape. So we'll start with the suggestion Antonio gave us with the last one like this. You got to get 0 on one side. So we're going to move that 2 to the other side. It's going to be 1 over x minus 2 is less than or equal to 0. Okay. But we can't start looking for critical points just yet. You've got to write this with one expression. So let me think of this 2 as being 2 over 1. What's a common denominator for this problem? Try again. What's the lowest common denominator? Thank you, x. So I'll multiply by 1 in the form of x over x. And that gives me 1 over x minus 2x over x is less than or equal to 0. Great. Looking good there. And finally, because I've got common denominators, now I can bring those two together. 1 minus 2x over x is less than or equal to 0. This is where you can count on your problems starting from me when you take an exam. Because I think these problems are hard enough as it is without dealing with that extra step. So count on them from here. I need to find our critical numbers. That's going to mean where the numerator equals 0 and where the denominator equals 0. I'll solve the denominator equals 0 for you. 0. So we're cool there. Where does the numerator equal 0? What's the advantage of moving the 2x to the right-hand side rather than moving the 1 to the right-hand side? Anyone?
Keeps it positive.
Yeah. Way to go, Kes. Makes it positive. So we get 1 equals 2x, and I don't have negative 2x equals negative 1. I got rid of all the negatives, so good job there. So what's that give me for x? Yeah, I get 1/2. So those are your two critical numbers. We can put those on a number line and test some points. So I've got a 0 here and a 1/2 here. You have to be a little bit clever in testing points here because it's tough to squeeze something in between 0 and 1/2 because our tendency is to think of integers. Before I do anything of that testing nature, how about this part? What intervals should I write? Negative infinity gets a parenthesis, and then 0. Can I use a 0? It's a less than or equal to.
Yeah.
I can use 0? What's wrong? What would happen if I tried to put in a 0 here? What would I be dividing by? 0. Can you divide by 0? No. So that gets a parenthesis. But 1/2 would make the numerator 0. That's okay. I'd end up with 0 is less than or equal to 0. So 1/2 gets a bracket like that. And so we're going to test some points now. That means I've got to change the expression that I have in my calculator. We're going to put that one in our calculator. Put this in the graphing calculator. Is there any preference in terms of how you do it? Which way did you guys like when we were graphing this or working with this? Do you like putting it in with the parentheses, or do you like putting it in with, the straight up and down fraction? Or doesn't it matter? Which one are you doing? Parentheses? Okay, I'll do it with parentheses. The nice thing about parentheses is that you get a decimal value as opposed to sometimes it'll give you a fraction. So it'll be parentheses 1 minus 2x divided by x. You're going to need to give yourself some test points. So why don't you see if you can't come up with a few test points and then decide which interval or intervals you want here. Josh, some test points?
Can you do negative 1/2? Or
Sure. You can do negative 1/2. Sure. What am I going to put in this interval? Just kind of a suggestion here. You can think of 1/2 as being 0.5. Can you think of a number between 0 and 0.5? Sure. 0.2? Yeah, why not? 0.2, that works out great. I need one more, Josh.
and then just 2.
Sure. So negative 0.5, 0.2, and 2. Let's go up to our table. Second graph. Let's delete all these old ones. Negative 0.5, which is our negative 1/2, 0.2, and 2. What information do I need from this graph here? Or from this table, I should say. Yeah, I need to know where it's negative and positive. So that's going to happen at a couple points. That's going to happen, well, the overall pattern is negative, positive, negative. Oftentimes, not always, but oftentimes they do alternate. Oops. So, you know, if you see a negative, positive, negative alternating pattern, that's somewhat reassuring. I mean, there are some exceptions. But which intervals do I want? Or which interval or intervals do I want? Do I want the positive ones or the negative ones? Negative ones. Here and here. Now the reason we're doing testing points here is because the graphs are much more complicated than what you have with a parabola. So it's easier just to focus on the bare minimum that we need, which is negative, positive, negative. In this case, because this is less than or equal to 0, we want the negatives. Be careful about the endpoints. You can't include the endpoints where the denominator is 0. If you're unsure, you can test the endpoints. If you try plugging in a 0, it says error. That's a big clue that you don't want to use that as one of your answers. If you choose 0.5, oh, you get a 0. 0 is less than or equal to 0, so that's okay to use. But the other one doesn't work because you can't divide by 0. That's why you're getting the error there. All right, there was a lot today. Comments or questions or thoughts on the last one? Doing good? All right, let's make this one a wrap and get it recorded.